So in this video, we're going to be talking about how you can find the vertex of any parabola given any equation for a parabola. It doesn't matter if you're given your equation in standard form, factored form, or vertex form. This video will show you how to find the vertex of your parabola. First, let's talk about what a vertex is. Graphically speaking, your vertex is either your local minimum or your local maximum. It will be your minimum if your parabola is shooting upwards to infinity, and it will be your local maximum if your parabola is negative and going down to negative infinity. I also would like to point out that your vertex falls on your axis of symmetry. Here, let me line up this dotted line a little bit better. In that, if we fold our parabola over this dotted line, it will match up perfectly. And the x-coordinate for your vertex is also your axis of symmetry. And you can see that in both of these parabolas here. If you're looking to find out what the coordinate is for your vertex and you have a graph, you can just count over to find the coordinate. Like for our green parabola, we're going over -1, 2, 3, and down 1, 2. So this coordinate is -3, -2. And then for the coordinate of our blue parabola, we're going over 1, 2, 3, 4, and then up 1. So this coordinate will be +4, +1. Okay, so with that bit of a refresher in some terminology, let's talk about how we can find the vertex if we are given the standard form equation of a parabola. Now recall that standard form is y equals ax squared plus bx plus c. And the way to find the vertex if you're given the standard form is to use this little formula such that the x-coordinate for your vertex is found by this equation, -b over 2a. And then you'll take that output and plug it back into your given equation to find your y-coordinate for your vertex. So let's shrink this down and put it to the side so we can still see it, but it won't be so much in the way. Okay, so let's have an example. What if we are given the equation of 3x squared minus 6x plus 4, and you want to find the vertex of this parabola? How can you do it? Well, just like we just talked about, we know that the x-coordinate of our vertex is going to be found by plugging in our b and a values into this little equation. What are the a, b, and c values of the given equation? Well, our a value is 3, our b value is -6, and our c value is 4. So whenever we plug it in, we have -6 over 2 times 3. And then we, of course, can simplify such that we have +6 over +6, which is just 1. So the vertex, which we're looking for, is going to have an x-coordinate of 1, and we still need to find the y-coordinate. We're still looking for our y-coordinate, but we know that the x-coordinate is 1. So we're going to take our equation and we're going to plug in the value of 1 in for x. And then we will have our y value for our vertex. So 3 times 1 squared is 3. 6 times 1 is 6. And then we have +4. So altogether we have 3 minus 6 plus 4, which is just +1. So our vertex for this equation is 1, 1. Excellent, excellent job. Here, let's erase this and do another example. Here we go. So I'll delete this. Okay. So let's say for our next equation, what if we have the equation negative x squared plus 4x? And why don't you pause the video and try to solve this problem on your own? Okay. So the first thing is we need to look for our a, b, and c values. Here our a value is negative 1, our b value is 4, and we don't have a c value, so we can just say it's 0. Next, we want to plug in our a and b into our x-coordinate formula of negative b over 2a. We can do that, and we can get negative times 4 over 2 times negative 1. Then we simplify to have negative 4 over negative 2, which is of course equal to positive 2. And so that tells us that the x-coordinate for our vertex is positive 2. Next, we'll plug in our positive 2 in for x. So we have negative positive 2 squared plus 4 times our positive 2. Here, let me just get the proper color in. And now we can simplify our expression to find our y-coordinate for our vertex. So we have negative 4 plus 8, and negative 4 plus 8 is positive 4. So the y-coordinate for our vertex is 4, telling us our vertex for this function is going to be 2, 4. Great job. So let's try one more example for standard form, and then we'll move on to factored form. So tell me the vertex. This is going to be a little bit of a harder one. What if we're given 4x squared plus 1/2 x plus 3? And I want to know the vertex of this equation. Again, go ahead and pause the video and see if you can solve it on your own. Okay, so first step is to find our a, b, and c values. Our a value here is just 4. Our b value is positive 1/2, and our c value is 3. Next, we're going to use the formula for our x-coordinate of negative b over 2a, and we're going to be plugging in our b and a values. So we have negative times a 1/2 over a 2 times a 4. And so we have negative 1/2 divided by 8. Remember that dividing is the same thing as multiplying by the reciprocal. So we have negative 1/2 times 1/8, which is just negative 1/16. So the x-coordinate of our vertex, it's no longer 2. Our vertex is no longer 2, 4. Our x-coordinate is negative 1/16. Okay, so now we're going to plug in negative 1/16 into x for our equation. So let me rewrite it with the proper gaps. I like getting the proper color in. Okay, so we have negative 1/16 here and negative 1/16 here. And we want to find the y-coordinate for our vertex. So negative 1/16 squared is going to be positive 256, or 1 over 256. A 16 squared is 256. And this is going to be times a 4. And then plus, well, 1/2 times a negative 1/16 is actually going to be a negative. So we're going to write a negative 1 over 32. And then plus a 3. Now we still need to simplify. 4 over 256, 4 times 1 over 256 is 4 over 256. And this simplifies. They're both divisible by 4. And what would that be? That would be, here, let's go out to the side. 256 divided by 4. 4 goes into 25 6 times. We have one remainder. 4 goes into 16 4 times. So 4 over 256, we're going to write this as 1/64th, as we just simplified 4 over 256. So 1/64th minus 1 over 32 plus 3. So to combine fractions, we need to have a common denominator. So I notice that 64 is just 32 scaled up by a factor of 2. So I'm going to change the 1 over 32 to be 2 over 64. And so 1/64 minus 2/64 is negative 1/64 plus 3. And then this we can of course write as a mixed number. And this is going to be 2 and 63/64. So our vertex for this equation is negative 1/16 and 2 and 63/64. This one was a bit of a harder one, but if your teacher throws in fractions, you need to know how to work with them. Great job. Moving forward, let's talk about what if we're given equations in factored form. Again, factored form is whenever you're given your parabola in the equation that looks something like this, some x minus a times some x minus b. Okay, and how can we find the vertex? Well, there's actually kind of two ways to solve these problems. One, I want you to remember that a parabola looks something like this. Here, let's just make something up. Looks something like this. In that the points where your parabola crosses your x-axis, these are your x-intercepts, also called your zeros. And your zeros are whenever your output, your y value, is 0. And that's super easy to find whenever your equation is in the factored form. Because for what value of x would the expression x minus a be 0? Well, that would just be when x is equal to a. And similarly, you would say, well, if x is equal to b, then x minus b is 0, and this full expression would be 0. So this is how you find your zeros. And again, notice that your parabolas have a nice line of symmetry. And so the x-coordinate for your vertex, will be the average of your two zeros. So the x-coordinate for your vertex is going to be your two zeros, a plus b, divided by 2. It's going to be the average of your two. And then you can just take your x-coordinate, plug it into your equation, and find your y-coordinate. So here, let's move this to the side. Let's shrink it some. I won't delete it, just in case you still kind of want to see it as a reference for what we're doing. But let's go ahead and delete these red lines. Here we go. And I'll also shrink this up a little bit just to give us some more room. Excellent. So let's do some factored form examples. What if we're given the equation y equals x minus 2 times x minus 4? how can we find the vertex given this equation in this factored form? Well, again, we're going to be looking for the zeros of our function. And remember that the zeros are just whenever each of these individual terms can equal 0. So when does x minus 2 equal 0? Well, that's whenever we can add 2 to both sides, and that's when x equals positive 2. What about for this right-hand factored? We have x minus 4, we set it equal to 0. We can add 4 to both sides to get x equals positive 4. So we see that our zeros are positive 2 and positive 4. Again, think to a graph. If we have some graph here, I'll draw it out. This tells us we have a 0 here and here. We're at 1, 2, oops, that was at 5, a 0 here and here. And we have a positive graph, so it's going to shoot up to infinity, but it's going to have to meet at some bottom point and have a local minimum, and our vertex will be directly in the middle. So what's the average of 2 and 4? What's directly in the middle of 2 and 4? But 3. And we can of course go out to the side and say 2 plus 4 divided by 2 is equal to 3. So 3 is the average. And so we know that for our vertex of our equation, we know that the x value for our vertex is 3, and we still need to find the y value for our vertex. So to find the y value, here let's clear this up a little bit. To find the y value, we're simply going to plug in our x value into our equation, just like we did in the standard form version. So we have, and again, you know me, I like getting my colors right. So I use this red color. So we have 3 minus 2 times 3 minus 4. So 3 minus 2 is just 1, and 3 minus 4 is negative 1, and 1 times negative 1 is negative 1. Therefore, the y coordinate is going to be negative 1. Excellent. So this is how you can find the vertex given the factored form. Let's clean this up and try another example. Here we'll erase this. Oops. Yes, we'll erase this. Okay. Delete. Let's say we are given the equation negative 2 times x minus 2 times x minus 5. And here, I'll erase this too. We might still use it. I'll leave the coordinate system, but I'll erase the parabola I made. Okay, so we want to find the zeros for this function. This is a function, so we'll say y equals it. Again, to find the zeros, we just want to know for what value of x will make this term equal to 0, and what value of x will make this term equal to 0. We do this because anything times 0 equals 0, so it doesn't matter if this left-hand side or this right-hand side equals 0. If either of them are 0, then the whole expression will be 0. All right, so when does x minus 2 equal 0? Well, we can add 2 to both sides and get that x is equal to 2. And then similarly, when does x minus 5 equal 0? Well, we can add 5 to both sides and get x is equal to positive 5. And so again, if we're looking at this on a graph, we have a 0 here at 2 and a 0 here at 5. This is a negative parabola because we have a negative out front. So we're going to have some parabola that goes down and looks something like this. And the x-coordinate of our vertex is going to be right on our axis of symmetry. And we're going to find it by doing 2 plus 5. 2 plus 5 divided by 2. That's the average of our two zeros. And we get 7 over 2. So 7 halves is the x-coordinate for our vertex. So let's change this up to 7 over 2. And now we are looking for the y-coordinate. So here I'll move this out of the way. I'll shrink it down and move it just in case you still want to look at it for a moment. Here, I'll put it here. Okay. Okay. Now we want to plug in 7 halves for x. And so we have negative 2 times 7 halves minus 2 times 7 halves minus 5. So what is 7 halves minus 2? Well, you can think of this as negative 2 times 7 halves minus 4 halves times 7 halves minus 10 halves. And then you can just simplify. We have negative 2 times 3 halves times 7 halves minus 10 halves is negative 3 halves. And we multiply all this through, and what do we get? Well, 3 halves times 3 halves, or 3 halves times negative 3 halves rather, is going to be negative 9/4. And then this negative 2 cancels with this 4, and the negatives cancel to leave us positive 9/2. So the x-coordinate the y-coordinate for our vertex is 9/2. So a moment ago, I referenced the fact that there's actually 2 ways to solve for the vertex given the factored form. Let's use the second example here. The second example is simply multiplying through the factored form, and that will give you the standard form. So if we FOIL x minus 2 times x minus 5, what's our output? Well, x times x is x squared. X times minus 5 is minus 5x. Minus 2 times x is minus 2x. And minus 2 times minus 5 is plus 10. Of course, this is all times a minus 2 on the outside, but we can combine our like terms and multiply in our minus 2 to get minus 2x squared minus 14x minus 20. And this will actually be a plus 14x. And again, we got the 14x by minus 5x times minus 2x is minus 7x. And then minus 7x times the minus 2 on the outside, it will give us the positive 14x. So whenever we multiply through our factored form, we get a standard form equation. And now we can use our standard form process to find the vertex. Recall that for standard form, we want to list our a, b, and c values, a, b, and c. So the a value is negative 2, the b value is 14, and the c value is negative 20. And then we will use our formula for our x-coordinate of negative b over 2a. So we plug in negative b, so we have negative 14 over 2 times negative 2. And this leaves us with positive 7/2. So notice that we get the same value, just as we should. And then to find the y value, you do the same process of plugging 7/2 in for x. And since we already did that, I'll leave that as an exercise to you guys to verify that your output will again be 9/2. Great job. Let's do one more factored form equation before we move on to vertex form. Here I'm going to clear up the majority of this. Okay, delete. So let's try one more factored form. In that, let us have our function being y equals x times 4x minus 3. And we want to find the vertex for this function. So this one's a little bit different in that our first expression is just the x. And then our second expression is 4x minus 3. However, the process is still the exact same whenever you're looking to find your zeros. You're going to set this first expression equal to 0, and then, hey, it's already solved. So this full term, your output y will be 0 whenever x is 0. And you can see that here. For our second expression, we have 4x minus 3, and we set this equal to 0 to solve for our 0. We can add 3 to both sides to have 4x equals positive 3, and then we can divide by 4 to get x equals 3/4. So the two zeros for our function are x equals 0 and x equals 3/4. Next, we simply find the average of these two. So what is the average of 3/4 and 0? Well, you just do 0 plus 3/4 divided by 2. This ends up just being 3/4 divided by 2, or times 1/2, which is, of course, 3/8. So the x-coordinate for our vertex is going to be 3/8. Next, let's clear this up. Next, we're just going to plug in 3/8 for x in order to solve for the y-coordinate of our vertex. And so here we have 3/8 times 4 times 3/8 minus 3. So 4 times 3/8 is what value? Well, notice that your 4 and your 8 can simplify and leave you with 3/2. So in parentheses, we have 3/2 minus 3. And then this is all still multiplied by our 3/8 on the outside. So let's change the minus 3 to a minus 6/2, just so we can have the same denominator. The 3/2 minus the 6/2 is going to be a negative 3/2. And a negative 3/2 times our 3/8 gives us what value? Well, 3 times negative 3 is negative 9, and 8 times 2 is 16. So we have 9/16, and this does not simplify. So the y-coordinate of our vertex is negative 9/16. Great job. If you have any more questions on this, let me know down in the comments below. But let's go ahead and move to the vertex form. Now I say vertex form for last because it's the simplest. So the vertex form of your equation is given to you as y equals a times some x minus h squared plus k. And your vertex is simply hk. That's why it's called vertex form, because the vertex in this form is staring you right in the face. So let's look at some examples. Let's say we have the equation y equals 3 times x minus 2 squared plus 4. What would be the vertex for this equation? Well, even though this is a minus 2, your h is a positive 2. And then your k is still 4. So your vertex for this equation is going to be positive 2, 4. And so think about that. That's the only tricky part with the vertex form, is knowing that the sign will flip for whatever is next to your x. Okay? So let me give you a few examples for you to solve on your own. What if we have y equals 2 times x plus 4 squared minus 5? Y equals 5 times x minus 3 squared minus 6? And y equals 2 times x minus 7 squared plus 7. Go ahead and pause the video and see if you can determine the vertex for all three of these equations. Okay, so for this first equation, the vertex is going to be negative 4, negative 5, as your h value here is a positive 4. Or rather, your h value is a negative 4, okay? And you know that because this 4 here is positive, and you're always going to flip the sign for this one here. And that's just because the vertex form, it's given to you as a minus h. And so if you see a positive 4 here, you know your h must be negative. Okay? The vertex for this second equation is going to be positive 3, negative 6, and the vertex for your last equation is going to be positive 7 and positive 7. So if you got all three of those, give yourself a pat on the back. Great job, everybody. This is how you can find the vertex of any parabola given any equation. If you have any more questions for me, let me know in the comments below. If you haven't already, hit that subscribe button, and I'll see you in the next video.